So the whole reason for this whatever lesson is to explore what we call rational exponents. Rational means fraction. Okay? So what I see here, so what you see right here for the exponent, right? That's a rational exponent because it's a half, it's a fraction, it's 1/2. Okay? So if you fill this out, you're gonna notice this.
Oh, not negative 21. 30. That's.
But here, let's keep on.
Yeah,
No,
no,
we-
no, no, keep going, keep going, keep
Because we need to
going.
prove that the remainder is the same, so you guys understand.
Yes.
Right? And then if I do the negative exponent, it's gonna be 1/9, right? 1/16,
I hate to see this more, that doesn't make sense.
1/25,
What's my remainder?
right?
What's my
It's
remainder?
gonna be 1/36. It's gonna be 1/49. Right?
No, honestly, bro,
So what we
I've
have
actually-
noticed
I've actually
is
seen that, I've actually done
the
that.
negative exponent, it's the flip of the positive exponent, right? Now, with the exponent to the power of half, I have to, my answer are the following. If I do 9 to the power of half, what do I get? 3. 16 to the power of half.
Form shows that one.
25 to the power of half. So what do you notice? What's the relation between what you see here and what you see in the previous two?
Rest my friend.
Go ahead, Mike.
I don't know, actually, they all have to use the same number.
So the first number is gotta be x3.
What do you, if you're gonna compare these, which is your basis here,
Yeah.
to these.
Same, but you have exponent for
But the answers of those are flip of the
Let me ask
The
you.
answer of those are the base of the exponent of a half, right? And the answer of those, with the exponent of a half, is the base of your exponent too. Now, can you guys tell me what is this? Like when you put on your calculator 4 to the power of half, you get a 2. 9 to the power of half, you get a 3. 16 to the power of half, you get a 4. Does this remind you of anything? What?
When you, it reminded me of when like you get a task back, and you want to figure out what the percentage is. It's kind of
It's not what I'm looking for. Maybe if you, I don't know, that reminds me of that.
For a line, you know, when we design, it says M is rise and root 1. The
Yeah,
1
but-
and root
Not that either. No.
you two steps.
36 to the power of a half equals to 6. I'm gonna ask you a question. What is the square root of 4? What is the square root of 9? What is the square root of 16? What is the square root of 25? And what is the square root of 36? And do you see anything in common now? So the power of half is the same thing as the square root. A power of a half is the same thing as square root. Now, can I scroll up? Now, what have you noticed here? What's 4 to the power? 27 to the power of 1/3. 27 to the power of 1/3. What do you get?
Yeah, 2.9.
No.
Three.
And you're not putting your calculator right. It's actually 3.
Is that cube?
You have to put 27
You say.
power, open bracket.
Oh,
Yeah.
I just did 0.3.
No, because 1/3 is not 0.3. It's 0.33333333, and
Well, I did 4.
so you're not gonna get the exact answer. Okay? Now, when you do 64 to the power of 1/3, 4. Something that I want you to remember, when you're putting this into the calculator, you're gonna put 27 to the power of open bracket 1/3 close bracket. If you don't do that, your calculator is gonna think you're doing this. 27 to the power of 1 divided by 3. This is what your calculator is gonna think. And they're not the same answer. This is gonna give you an answer of 9. This is gonna give you an answer of 3.
On my calculator, if I do it the second way, if I pass them both the second time, I'll get the right answer.
Yeah, because you're dividing by 3 twice, and that's not also right. In this case, it would work, but technically in other numbers, it will not work.
Go ahead and say, would you?
Okay?
But in my calculator, it can work without.
Yeah, yours is because it already keeps it in the exponent. But not all calculator keeps it in the exponent. You're good too.
So how are you doing that?
27.
So,
Power. Yeah. Bracket. 1/3. Okay? You have to put the bracket.
Oh, so there's.
Okay.
Oh, you do.
Same thing, as I said. 27.
You're doing this for a while.
Exponent. Open bracket. 1/4. Okay. So, can you guys tell me what, again, what do you see? What kind of relation it is?
I don't know.
Cube root.
Yeah.
The relation is, again, the answer, the base of this is the same thing as the answer of that, right? And vice versa. The answer is the base, right? So, again, power of 1/3 is the same thing as writing the cube root of whatever the base is. So the cube root of x is the same thing as x to the power of 1/3. Okay? They're exactly the same thing.
There are no remainders. Oh, yeah.
Okay.
You have to say you look at track for
You must have done it before.
Yeah.
Okay. Let's do 5.
Okay. We have already compared the answers for these. So the answer in the second column is the inverse or the reciprocal of the answer
Yeah, 1 hour.
in the first column, right? We talked about this. We talked about that if I have 2 to the power of 1, that's, sorry, 2 to the power of, let's say, 3. 3 to the power of 2, I get 9. But if I have 3 to the power of negative 2, I get 1 over 9. Right? Because technically I'm going to flip my base and I'm going to make it into a positive exponent.
Like,
Yeah.
you're
Just like.
Okay, I got the same thing.
Comparing the first and the third column, the base of the first column is the answer of the third column. That's okay. And the answer of the third, the answer of the first column
It's not his job. Yeah, it's not his job. Honestly, if I was him, I'd be like, fuck you. That's what I would do.
is the base of the third column. Okay? Remember that what I had is, let's say if I had 3 to the power of 2 is 9. 9 to the power of half is 3. So, the base here is the answer in the third column. And the base in the third is the answer in the first. Right? And what we see is, we see that our exponent is the reciprocal exponent. So this is a 2, this is a 1 over 2. Okay? So they cancel each other. Right? The square and the square root, they cancel each other. When you multiply.
Yeah, because I find this because I want to reach to the surface and I say
Yeah, that's right, that's exactly.
this is just I say how.
So we learned that an exponent of 1/2 is
Can you just help me?
equal to a square root. And an exponent of 1/3 is equal to third cubic root. What do you think an exponent of 1/5 would be?
5 square. 5 root.
Okay, that's right, the 5th root.
5th root.
Yeah. That being said, I can come up with this new formula that says a to the power of 1 over n is the same as n root of a. Now, if the exponent is not 1 over, it's actually a number over another number. Okay? So, to do a fractional rational exponent on your calculator, you will need to use an exponent button on your calculator. So the exponent button can look anything like this. You know it. Use bracket around the fraction. So let's say if you're putting 25 to the power of 3 over 2, you're going to put 25, your exponent button, bracket 3 divided by 2, close bracket. I just showed you that with the 1 over 2, right? So you guys are going to tell me what happens. What do I have? 1 to the power of a half. What do I get?
Is 2 square now.
1 to the power of half.
Well, yeah.
So that's 1. 4 to the power of half. What do I get? 9 to the power of half. 16 to the power of half. Is 4. Now, for the second column, we're going to have to do 3 over 2. So 1 to the power of 3 over 2 is going to be 1. It's not going to change. Oh, anything 1 to the power of anything is 1. What if I have 4 to the power of 3 over 2? Can you guys do that on your calculator for me, please? 8. It's 8. How about 9 to the power of 3 over 2?
27.
How about 16 to the power of 3 over 2? What was it?
64.
Good. Do you notice anything? Or no? I want you to look.
3. We take 1.
I want you to look at this answer and this answer and tell me what do you think? What's the relation between the two?
3 in the base. 2, the base is 9 per 3, 16 per 4.
3 is
Multiply.
3 exponent 3.
We
See
take
left? Sorry. So what you're thinking is you're thinking about these two, right?
Yes.
I don't want you to think about these two. I want you to think about this and this. Ila, what did you say?
I say it's 2 exponent 3 becomes 8.
How about 3 exponent 3? What does it become?
27.
How about 4 exponent 3? What does it become? So what's the difference between this and this?
The answer is the cube of the.
Yes. Let's look at this for a second. This I can actually write it like this. Can't I? Because what's a half times a 3?
3 over 2.
3 over 2. And this,
Oh, yeah.
this right here, is this.
Yeah, I see.
Do you see that?
The base.
This is right here. It's the base right here. And then you're raising it to the power of 3. So let's write this as a root. So what would this root be? Square root of a to the power of 3. Okay? Now, what do you think this is going to be? The a to the power of 5 over 2.
Cube of 5.
What?
Square root of 5.
Yeah.
Square root of a to the power of 5, you mean. Right? Yes. So let's do it on a calculator. So I want you to do 1 to the power of 5 over 2. We already know that's 1. Do 4 to the power of 5 over 2 for me.
32.
9 to the power of 5 over 2.
243.
16 to the power of 5 over 2.
1,024.
So, if I raise 2 to the power of 5, what do you get? 2 to the power of 5. Should be 32, without using my calculator. What's 3 to the power of 5?
2 for it.
It is. 4 to the power of 5. مش ضربناها رفعناها على
Exponent.
So, that being said, this is the same thing as 1/2 to the power of 5.
And same thing,
Square.
square a power 5.
That's why, because I want x by itself.
That's
Right.
it.
That's what you're looking for.
Okay?
X by itself.
Because remember, a half times 5 is 5/2, which is this.
6.
We're gonna do it by fraction.
I just want to switch it to this one.
So I'll show you how to do it by fraction.
I'm not going to explain this. This is exactly the same idea. I'm just going to put the numbers in.
So the second one is 1/2. Sorry.
No, I did. Yeah. So I understand. Yep, I wanted.
3 to the power of 5 is what? 243.
Yeah. That's 3 to the.
Okay, so the formula for the second one is gonna be A
Oh, okay.
1/2 exponent 3. The second one. And the first one, A 1/2 exponent 2. First one.
Just a to the power of 1/2.
Oh, that's it. Not exponent. Just A/1/3.
To the power of
Or what?
No, that's too much.
this, just as it is. Doesn't change. So if I want to write these in terms of splitting them, this is going to be the same. So a to the power of 1/3, or in other words, it will be cube root of a. This is a to the power of 1/3 to the power of 2, right? Because if I multiply my exponents, 2/3, which is in other words, cube root of a to the power of 2. And this is a to the power of 1/3 to the power of 5, which is the same thing as writing cube root of a to the power of 5. Now, can you guys tell me what's happening with my numerator and my denominator of my exponent? So where is the numerator going? So if you're looking at your exponent, right? Where's your numerator going? And where is the denominator going? So if you look between this and this, where's your denominator going?
In a exponent.
Oh.
5,
Yeah.
exponent.
Okay. Where is the denominator? Where is the 3 going? It's going in for the root. Where is your numerator going? So the 5. It's the exponent. That's going to be the case every single time. So, no matter what your exponent is,
Yes.
I'm just going to, I'll scroll back.
I'll read it.
Exponent,
5.
right? Always, your denominator is going to go in the root, and your numerator is going to go outside as an exponent. There's 2 ways to write this. You can write it like this, or you can write it like this. It's going to be exactly the same answer.
How come it's not?
Okay? These are both the same thing.
Same difference.
So you need, first you have to cube root, and then whatever the answer is, you have to square it. Make it 5, so we will do that 5 times.
You have to root it. Whatever the number is for the denominator, that will be the root. And then whatever number is in the numerator, that will be your exponent. Yeah, because that's the x.
Alright, so now I'll just